Hello, everybody, and welcome to our new book, which is orange, and it's called Probability. So probability is the chance or the likelihood of something happening in the future. So first page is our word bank. So an event is a set of outcomes. A set can be one or more. A set of outcomes of an experiment. And the symbol for the word experiment is E, capital E. So if you see a capital E, that means the word experiment. So for example, a very simple experiment would be if you take a dice and roll it, what would be the chance of, for example, getting a 3? So that would be the experiment. And the outcome would be to roll the dice, and you do actually get a 3. Okay, experimental probability is the result of an experiment. So for example, if you, let's take a coin, a quarter, and you flip it 100 times, that would be an experiment. And the result would be how many heads and how many tails did you get? With an experiment, the more you repeat it, the more accurate your results are. So that's why you're going to flip it 100 times and not just 5 times. You flip a coin 100 times and you get 53 landing on heads. And the rest, which is 47, landing on tails. A fair game is there's an equal chance of winning or losing. So for example, sometimes they have dice that are actually not fair and they're weighted down on one side. Maybe they always want to get a number 6, the highest number. And so some people will actually put a weight into that side where the number 6 is. And so therefore, when you roll it, it comes up on that number most often. That would be not fair. That would be unfair. So a fair game is, let's say you draw a card from a deck of cards without looking, because if you look and pick one, that wouldn't be fair. If you want to draw a card at random, you are not allowed to look, right? So I'm going to use that for an example. Not looking at cards when you draw a card. The word outcome means it's a possible result in an experiment. So there's a slide I want to show you on that one. Possible result and outcome. Let's say you have one dice. This is called one die. That's singular for dice, actually. So you have one die and you roll it and you get a 2. So there's one possible result because there's 6 possible outcomes, right? Because you have 6 sides and 6 numbers on a die. So if you roll a 2, that's just one possible result or outcome. If you take 2 dice, that's dice, plural, and you roll it at the same time, you get 2 possible number combinations. You might roll a 4 on one die and a 6 on the other. So your combination is 4 and 6. So there's there's more outcomes possible, but this is one of the possible outcome. And I'm going to show you later how many there are. If you roll 2 dice, how many possible outcomes you can have. Okay. Okay, probability. The word probability means the measure. So we're measuring the likelihood or chance. It's called likelihood or chance of something happening. It's called an event. You can use the word something or event happening. And it's usually talking about the future because in the past you know what happened. You already can tell. We look back. But if it's like, let's say you want to roll a dice and you want to get a 6, that's you're looking at it before it's happening. So we're talking about the future. Okay. And the capital letter P stands for probability. So anytime in the book you see capital P, it means probability. All right. And it's always a number. So we measure it with a number between, so that a measure has to have numbers 0 and 1. It's always a number between 0 and 1. So 0 means it's not going to happen at all, ever, no possibility. 1 means it's certainly going to happen, for sure. Okay, so anything in between, we're going to assign a likelihood or a number, and then you kind of know, oh, there's a 50-50 chance. Yeah, so that's a half and half, and we're going to learn how to assign likelihoods to these numbers. A probability experiment is a test you repeat often. So has to be repeated. The more you repeat it, then the numbers are going to tell you more accurately. So the more you repeat it, the more accurate this number between 0 and 1 is going to be, or the measure. So it's a probability experiment, is a test you repeat often to find, so let's not put a period, to find the chance of something happening in the future. So one of the example for this is when you look at your parents' phone and you look at the weather app, and it'll tell you, like today it's raining right now. So it'll give you a percent of chance of rain. It'll say 30% chance of rain, 100% chance of rain, 50% chance of rain. Well, that's for the future. That's later on today, right? You notice it's always predicting what is the weather going to be like the next few hours or the next day. And how do they do that? Well, they have measured, they don't have a crystal ball when they put those numbers in. They actually have measured the weather in similar situation up in the clouds in previous months or years, and they collected all that data, and they said that if the situation up in our stratosphere is that way, half of the time in the past it has rained. So therefore we predict it will do the same again. And that's measuring probability and using numbers often repeated to predict what the weather is going to be like in the next few hours. And it's a percent. So, and it's usually up to 100%. And 100% coincides with the number 1. So the number 1 stands for 100%. And the number 0 is 0%. And then the spectrum in between will give you the measure of something happening. So the weather report is a probability experiment. For the next day or next few hours. Or next day. Sometimes it goes all the way to the next week, but then it becomes less accurate because we don't know exactly what's happening up in the clouds next week. We can look at the way the wind blows and how it's called the jet stream, how it behaves, but it's kind of unpredictable as far as making accurate. But for the next hours, they really, because they saw how it was in previous times. A sample is a selection taken from a larger group. So for example, and it should be at random, must be at random. Random means you're not looking, you're not making any decisions beforehand, you're just taking a sample at random. So for example, let's say you, let's say at our school, you want to know if people, well, our school is small, but let's say you're at a big, huge high school with 2,000 students and you want to know if they like the cafeteria food. Well, you're not asking every single student. You could grab, let's say 10 students or 20 students and ask them if they like the cafeteria food, and then their answers get projected on the whole population of the school. That would be a sample. However, you don't want to pick students who are first in line at the cafeteria because they obviously like the food. You want to make it random by maybe pick them as they leave the school, or take every 30th person walking out of the school, and that would be random. We don't have a cafeteria at our school, right? Okay, that's a sample. And then sample space is all possible outcome, all possible outcomes or results of an experiment. And often we have to find those to tell what the probability is and assign a measure or number. We have to know all possible outcomes or all possible results. And I'm going to show you another slide, and it's this one. So if you remember, we rolled 2 dice over here, the example 2 dice. You rolled 2 dice and you rolled on the first try a 4 and a 6. Do you see how it's written like a pair of numbers with a comma in between? So here's how many ways can you roll 2 dice and get these combinations? Those are the sample space or possible outcomes. So here's a list of all the combinations. So you roll them and you get a 1 and a 1, right? So you roll the 2 dice and you're going to get a 1 and a 1. The next possibility could be, it's not going to be in that order because that order is math. It's just listed all the possible outcomes. So when you actually do the experiment, it probably will be in a very different order. But these are the possible results you can get when you roll 2 dice. Because remember, we only have 6 sides. So there's 6 numbers. So you start from 1 to 1 possible combination to 6 to 6 and all the possibilities in between. So if you notice, you could roll a 1 and a 1, a 2 and a 1, a 3 and a 1, 4 and 1, 5 and 1, 6 and 1. Then we go to the 1 and 2, 2 and 2, 3 and 2. Notice here, let me talk about the order. It's called order matters. So if you call the 1 dice die 1, it's weird, right, to say die, but that's really the singular. And die 2, you got 2 dice. And you have to call the order, this is your dice 1, this is your dice 2. You notice that you have a 3 and a 2 and a 2 and a 3. Well, you'll say, well, that's the same combination. You have a 2 and a 3 or a 3 and a 2. Not if the order matters. If you keep dice 1, a 3, and dice 2 rolls a 2, then this is a different combination because now dice 1 rolled a 2 and dice 2 rolled a 3. I shouldn't put these in there because you'll think these are numbers. They're not. They're just the number of the dice. So the combinations, the different possible combinations, how many are there? This is called a sample space. How many different combinations, if order matters, are there? You have to count them. Of rolling 2 dice. You won't have this page, so you don't have to write this down, but you can refer back to it if you're playing at we're going to play dice games in the class, and you might need this, so you have to come back to it. Possible combinations of rolling 2 dice when order of dice matters. So if the order of dice matters, you're going to have more combinations than if the order wouldn't matter, because this would only count as one outcome, but it actually counts as 2. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's a 6 by 6. So there's 36 different combinations possible. And this is called the total. Sometimes you'll see me say, oh, you need to find out the number of total outcomes possible. This is what I'm talking about. So total means what are all the different things that can happen? All right. And then your job is to figure out with an experiment, how many times do you get a 4 and a 4? What is the chance of rolling, let's say, 2 4s or 2 6? And we can do that with an experiment. Remember, you want to repeat it 100 times, because if you only do it once, most likely you're not hitting it, but you will. If you do it 100 times, you will eventually get a 6 and a 6 combination. Okay, so this is the sample space, the word sample space, all possible outcomes. And a lot of times you can list them. So I'm just going to say, look at combinations when rolling 2 dice. Okay, theoretical probability. In theory, sometimes you hear the word theory. Well, in theory, you can do it, but in real life, it probably won't happen. Theory means there's a possibility, and it's usually using math, but in real life, it doesn't happen that way. So theory is more like, so in math, we call the math part of a problem is theory. So the math part in probability is theory. Let me just use capital P so we don't have to write probability. Remember, capital P is probability, is theory. So whatever numbers you get, remember we assign a number. Probability is the measure of likelihood of something happening, and we assign a number between 0 and 1. So the math you use is theoretically. In real life, it's probably not going to happen exactly like that. So that's called, the real life is called experimental probability. And they match close, but not 100%. The result will match closely. The result of the math and the real life experiment will match closely, but not totally. So I have a slide for that one. It's this one. This slide here has 2 compartments. The first compartment, I'm circling it with my cursor. I hope you see it. I'm not sure if you see these things on my video. The first compartment is called the experimental probability. You're rolling a dice 1,000 times. That's a lot. So that's what I'm talking about. You want to repeat it over and over and over, but nobody's going to roll a dice 1,000 times. But you can actually do it on a video game. Like you have, if you look at virtual dice games, you can do it. You just click, 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 and maybe we can find one together online. However, I want to make one thing clear at this point, that I do not want you to gamble in any way. Gambling is very dangerous. It causes addictions, and it's just not a thing to do for a young person like you guys are. I want you to stay away from that. If you look at virtual dice, stay away from any gambling games. Or when we talk about cards, like later I'm talking about card games, do not think I'm condoning or telling you to gamble. Very dangerous, okay? It can ruin your life if you get hooked on that stuff. So it's okay to have a little fun with it, but very dangerous. Please stay away from gambling. Okay, so you're rolling a die 1,000 times, and the number 5 appears, so you count. What are you getting on the first roll, on the second? You're counting, you're taking note of how many you get, and the number 5 comes up 140 times out of the 1,000 times you roll. So here's how we write it. Capital P, that's probability of rolling a 5. Do you notice how it's in the parentheses? This is how we write it. The probability of rolling a 5 is the desired outcome, which is 140 times, over the total number you did it. So you did it 1,000 times. So the fraction, remember, fraction is let's call it the success. This is what you wanted. You wanted a 5 over the total. Okay, so this is experimental probability. You can reduce that number to 14 over 100. So you would have a 14 out of 100 tries, and then you can reduce it even further to 7 out of 50. By dividing top and bottom by 2. So 7 out of 50 rolls, you should get a 5. This right here is the most accurate, 140 over 1,000. So this number is coming from an experiment. Yeah. So you actually did it. Real life. Most accurate when you do it in real life. The theoretical probability is the math. The math part tells you that the probability of rolling a 5, if you roll the dice one time, there are 6 total sides, right? 1, 2, 3, back 4, 5, 6. There's 6 numbers. So that would be your total. The total face, they call it faces on the dice or numbers, right? And there's 1 5. So we'll call that success. So 1 out of 6 is your theoretical probability, that math part, but in real life, 1 out of 6, I'm going to divide. So you need a calculator. I'm going to write that here because you will need a calculator for this. Oops, why isn't this thing writing? You will need a calculator for your homework, for anything. In class, we have them. I want you to grab a calculator, even if you have to get one online, but I like you to have one next to your desk without switching around on the internet. If you divide 1 divided by 6, so this is the fraction, then you use your calculator. Make sure when you divide, it's top divided by bottom, not the other way around. So 1 divided by 6 equals This is called the decimal version, 0.16, and it repeats, correct? Do you see how this repeats? So I'm gonna say that's your decimal. And then when you multiply this by 100 with your calculator, you get the percent. So you have fraction, decimal, percent. So when you multiply that by 100, and you have to round correctly. Rounding is a big thing here. So I'm keeping my answer in the calculator and just go times 100, 16.6%. So that's about 17%. So I'm rounding to the nearest. So the 6 tells me to round up. Okay, so 17% of the time you're rolling a dice, the number 5 comes up. That's what that means. Okay, let's look at the experimental probability. If you divide 7 divided by 50 to change it to a decimal, you see it's 0.14. That's your decimal. Then you multiply that by 100. And you get exactly 14%. So 14% versus 17%. Remember I told you experimental probability and the theoretical probability, they're not always the same, but they should be pretty close. I mean, they are pretty close. It's not like this is almost like 90% and this is 14%. Then there's a mistake, but it's fairly close. But the experimental probability, if you repeat the experiment so many times, this one, if you keep going and experiment and you make it maybe 1,000,000 times, this number will get closer and closer to the math number. The more often you repeat an experiment, the closer the results, like the percent, right, will be to theoretical experiment result. Okay, that's a fact, but you got to do it so many times, like sometimes millions. Okay, remember I told you that the probability of an event is a number between 0 and 1. This number right here is the number I'm talking about, between 0 and 1. It's a decimal. And that number tells you what's the likelihood or the chances of this happening. So you can change your decimal into percent by multiplying by 100. We start out with a fraction. The fraction measures your success over the total number of trials or how often you did it. Okay, so that's it. Fraction, decimal, percent. Those are the 3 ways you can express probability, likelihood of something happening. Okay. I think that's it. I'm just going to say see slide. Okay, so you have that to look at. If you watch the video, you can also take a screenshot and download it somewhere so you have it. So we went over the outcome, which is the result. And then we went over the sample space. What are all the possible results that could be happening? You have to count them. There's 36 when you roll 2 dice, if the order matters. And then we had experimental probability versus theoretical probability. Okay. Now we're coming to our very first page, which is page number 1, Introduction to Probability. And this is actually homework. So I'm going to write homework on top, but guess what? I'm going to get you started. But I'll put homework. Make sure you write that on there, okay? So what are we doing? Summary, we're learning. We will use vocabulary related to probability. We just wrote it down. You need to look at it. Every once in a while, you have to leave back in your booklet to remember what does the word mean. Make sure you do your vocabulary puzzle at the end, okay? We will write the probability of events using fractions, decimals, and percents. Remember, I just showed you those 3 ways of showing probability measurement. We will perform a probability experiment. We'll do that in class. So we have to all come to class in order to do that, okay? The goals of this lesson, which is 7.1, Introduction to Probability, is to understand vocabulary. We just wrote them down related to probability. Those words should be all new to you, okay? Is also to understand that the probability of a chance event is a number between 0 and 1 as a decimal. Remember, the decimal is the number between 0 and 1, and that's how we measure it. Yeah, we will use fractions, again, decimals, and percents to represent probabilities. And we will perform a probability experiment in class. Make sure you come to class. Okay, here's our warm-up. Donnie plays trombone, which is an instrument. You blow in it, a tuba or something like that, in the school band. His aunt buys a raffle ticket. A raffle ticket is like you can win a prize. To buy the ticket, you get a chance to win a prize to support the band's fundraiser. She asks Donnie, "What do you think are my chances of winning the raffle?" Explain what Donnie's aunt means by this question. So I can give you the answer. I want you to think of something. What does she mean by this question in your words? And you can look at your vocabulary list. So you can use some words from your vocabulary list to insert this here. What does she mean? What are my chances? Next, use percents to describe what you think each of the following potential responses. That refers to the future, right? We don't know. Might mean, okay? It is certain that you will win. If it's certain that you will win, it's 100% chance. Certain means 100%. It will really happen. It will happen for sure. Okay, it is impossible for you to win. It's a 0% chance. Okay, never. No way. No how. Okay, now the rest of these, unlikely, I'm going to show you where you can find a little help on that. Okay, so you're using a percent, or you're assigning a percent, just like I did here. Unlikely, probable that you win, possible that you win, improbable that, likely that you win. Okay, so here's where you go. I'm going to pause that for a second. Okay, I just inserted it on the next slide. So this is also on Canvas. In your assignment, if you click on it, you'll see the same thing, but I think it'll help you hear more. Virtually certain means greater than 99% chance. So you can kind of go by that. Extremely likely of something happening is greater than 95%. So these are the numbers I want you to pick from to insert on the previous page, right? Very likely, greater than 90%. So like 91, 92, the closer it gets to 100, the more likely it's definitely going to happen, right? With 100%, there's no way it's not going to happen, and so on and so forth. So then you go down, about as likely as not is anywhere from 33 to 66%. You can pick a number. 50% is half and half, yeah? Unlikely, less than 33%. So you would pick a number less than 33%, like 32%, 31%. Very unlikely, less than 10%. Extremely unlikely, less than 5%. So this is almost not going to happen. And exceptionally unlikely, less than 1%, which means like 0.5% or a 0.5% would be exceptionally unlikely. So your job on this page is to assign a percent to each of these. And then let's compare when we come back to class to see how you did, what number you assigned. Okay, so there's your homework on that page. Use this little list. And we're going to do this page. Now we're on page 2. This is one of these experiments we're going to do in class. So I have to wait till you're all back, and hopefully you all will be after spring break. Okay, and we're using dice, and we're going to roll dice and record our findings. Okay, then the next page is page 3. This is homework again. And again, you can use the list I just inserted, this one, this list right here. Take a screenshot, or you have to go back and I don't know how you're going to do it. Can't figure it out right now, but it's there for you. Choose a word list. Choose a word from the word list below to describe each event. So on the bottom, you are having to use one of these words. So these are all the choices. Yeah, and your job is to figure out which one would you use. You will have math homework today. All right, most likely, right? I mean, most days I give you some assignment. So I would use the word likely. It's not certain, but pretty likely, or probable, or possible. So any of these you will have to insert. I'm using the word likely, and your rest is homework. Everyone in the entire school will do their homework tonight. What do you think about that? Yeah, now your job is to pick a word from down here. Is it possible? Yeah. Is it improbable? Is it impossible? No. Is it unlikely? Is it certain? You decide which word are you going to assign. That's a measure of that's a measure of probability. We measure, but this is more for you to predict and see what you think about these words. Okay. Oh, look at this, number 11. You will roll a number cube. That's a dice, just a regular dice. 6 sides. Oh, they call it die as a singular. Okay. And get a number greater than 1. You roll 2 dice and get a sum. Sum means you add the two numbers that you get less than 10. What do you think is the probability? You can experiment with that if you have two dice at home, roll it. And you're only gonna roll it once. It only says you will roll two dice and get a sum less than one. You only one roll. Not two, not three, and not until you get it. It's just on the first roll. Okay. Oh, and then it's talking about deck of cards. I'm going to show you a deck of cards if you don't have any at home in just a second, and then you can look at that so you know what's in there. Okay, so this page is homework. And then this page, we're on page 4. It's notes and in class. So there's this notes plus in class. We're going to do a lot of stuff in class because we want to do experiments, and we can only do them when we're together in class. Okay. The probability of an event or something happening, right? The probability, this is where you look at your vocab list in the front. You have to go back to it sometimes. Okay, and I will do the same. The probability of an event or something happening, the chance or likelihood something happening is a measure. It's a measure. So we use numbers to measure things of the likelihood of this to happen, right? For an event denoted capital E, remember on our first page, capital E, event, a set of outcomes of an experiment, capital E. The probability of that thing happening is denoted or written as the probability of an event. So here's how we say it. The probability of an event. And a lot of times it describes inside the parentheses what it is. Yeah. It will state what the event is. Like the probability of rolling a 1. That would be your event, and that would be inside the parentheses. But this is super important that you understand what these symbols mean, okay? All right, here, if an event is certain to occur, the probability of that event is equal to 1, which is 100%. Okay? Its chance of occurring is 100%. Okay, for sure. There's no other way. Okay, and that has to be, there really is no other way. Like the probability of the sun rising tomorrow is 100%. Yeah. If an event is impossible, impossible means there's really no chance. The probability of that event is equal to 0. The chance of it occurring is 0%. Never going to happen. Okay, all probabilities are between 0 and 1. Okay, that is 0 is, this is how we write it in math. So the probability of an event is between, see how it's wedged between 0 and 1? That's all this means. I'm going to read it to you. But really think of it this way. This is what we're doing, and the answer will be anywhere between 0 and 1. 0 is less than or equal to the probability of the event, which is less than or equal to 1. This is all it means. It's between 0 and 1. A number between 0 and 1. Example, in a coin flip, remember our coin, you got a quarter, 25 cents, and you flip it. And you want to flip it to where it's fair, because if your coin is weighted down on one side, it's not going to be fair. So then it always will come up heads. So your coin has to be a fair. If you flip it, the probability of see how they're using the word fair coin, will land on heads. We have heads and tail. There's only two things, right? On a coin, you got heads and tail on the other side is 50%. We may write, here's how it's written. The probability of it landing on heads is equal to 50%. This is your percent. The probability it landing on heads is 0.5, which is your decimal. And the probability it will land on heads is 1 out of 2, which is a fraction. So all these mean the same thing. They all mean the same thing. No difference. Here's your number between 0 and 1. The decimal is the number that is between 0 and 1. These are other representations of this. 50%, 1/2. They all mean the same thing. Okay? You will need a calculator to change from fraction to decimal to percent. So I'm warning you right now, you will not be able to do this at home if you don't have a calculator. I would suggest you go to Walmart. They're not expensive, $13 maybe will buy you a good scientific calculator. I do not want you to use your phone. It's too distracting when you do your work, okay? And the computer is kind of cumbersome, meaning it's kind of hard to go back and forth between screens. Okay, so this is your homework here. Suppose slips of papers with the names of each student in your class are placed in a box. This we're going to do in class, actually. Okay, we're going to do this in class. So let me write in class experiment. Make sure you're in class. It's more fun when everybody's there, okay? And this is page 4. And now page 5, cards and coins. Okay, so in your own words, explain what you think for an event to be random. Write an example of a situation you think involves randomness. So, oh, by the way, this is notes plus in class experiments. Okay, so random means you do not manipulate anything, like looking at the cards before you draw one. That's my explanation. I can have you write your own. How about if you write your own here? I'm telling you, this is what I would say, but there's so many different examples. If you say, oh, here, friend, there's a deck of cards, draw one card. And of course, you want the person to draw the card without looking, because otherwise they can manipulate it and draw the card they want to draw. So that would be random, not looking, totally fair. There's no weight anywhere if you roll a dice, okay? And then your guys' job is to come up with a situation that involves randomness. Okay, so here we are talking about deck of 52 cards. So I have inserted 2 pictures of decks of cards, okay? So a deck of cards has 52 cards. It has 4 suits. These are called the suits. Oh, it tells you that up here. Okay, the ace is usually number one, but it can also be back here because sometimes it's worth more than the king, which is this one. So it depends. Your ace can be here or at the last to make it the most valuable card, or it just counts as one. So the clubs, diamonds, hearts, spades are suits, and you have, it starts at 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you have jack. These are called face cards. So I don't have room. Face cards. Okay. Jack, queen, and king, because they have faces. So these cards have no faces, or I don't like them. So I made another deck of cards for you with the actual faces. See how they have faces? This is the jack. See if we can make it bigger. Jack, queen, king, right? They all have faces. And then you have black cards and red cards. So you can count how many cards there are when you do your homework. In class, I'm going to have decks of cards. You can actually do it with the cards to draw at random. Okay. So this slide is there for you to look at when you do your work. So let's like, what is the probability of each event when choosing one card at random? No looking, right? From a typical deck of 52 cards, no jokers. Consider aces to be low, I equal to 1. The probability, this is your event. Remember, we wrote probability of an event happening. Drawing a queen of hearts. So now it's always what you want, or sometimes I use the word success over the total. The total is 52 cards. There are 52 possible cards, but we want a queen of hearts. So let's look how many are there. Queen, there are two queen of hearts. No, just one queen of heart. So it's 1 out of 52. So now, since there's only one queen of heart out of 52 possible cards, very low possibility. So to change it, this is your fraction. To change it, you divide 1 divided by 52. Do not say 52 divided by 1. That would make it totally wrong. It's the top divided by the bottom. So that's how you have to put it in your calculator. And then press equal, and you see your decimal version. 0.0192, and then it keeps going. We don't need that many decimals, and that's your decimal, and then you multiply by 100 to get your percent. So leave your answer in the calculator and simply multiply by 100. So this is your decimal. This is your fraction. And then times 100 is 1.9%. And you have to round. Okay, round correctly. Okay, so let's do one more. I think you can do this at home. I'm going to use, well, you can work, you know what? What we're doing, if we use that deck of cards in the back, it's called a mathematical probability, a theoretical probability. If we do it over and over again in class, it's called an experimental probability, but you have to do it over and over. Let's do one more. Draw a queen. So how many queens are in our deck of cards? 4 of them. 4 queens. So it's 4 out of 52. There are 4 queens out of 52 total. It always has to be that the top number is smaller than the bottom number or equal. If the top number is equal to the bottom number, means you have 100%. But usually the top number will be smaller than the total. Then you divide 4 divided by 52. And then you have to, you can use several decimals. And the next one is 9. That's the one I'm going to round up, and then multiply by 100 to get your percent. 7.7, I'm rounding up. And it's rounded, so I'm using the little about. Okay, let's see which one. Draw an odd diamond less than 5. The probability of drawing an odd diamond less than 5. So let's see how many are there. Diamond is this. Odd would make it less than 5. Odd. Oh, we can take the ace because it counts as 1 in this game. And we can take the 3. We are done because this is even, this even, and this is 5, but it says less than 5. So 5 doesn't count. This doesn't count. So there's 2 out of 52. Two out of 52. And then we have 2 divided by 52. That's our decimal, very small number. So the likelihood of that happening is very small. And I'm multiplying this number by 100 to get the percent. It's about 3.8%. So about 4% of the time you do this, you will get an odd diamond less than 5. Okay, so now your job is to, we're going to do this probably in class. We're going to flip a coin 200 times in class. That would be an experiment, right? So we're going to do that. And now I believe this is it. Here are your cards. And this is lesson 7.2. So we're stopping here. Good luck to you guys.